So here is the problem. You're given this vector field, x squared, y squared, and you're given a curve, y equals x, and it's part of the graph of y equals x squared from -1, 2 to 2, 8. So it might be helpful to look at that PDF that I put up about doing these problems and to see what we're going to compute here. But the first thing I'm going to do is parameterize that curve. I may not need this, but I'm going to look at it. So here's y equals x squared graph. And -1, 2 is about here. And 2, 4, I mean 2, 8. 2, 8. 2, 8 can't be on here. 2, 4. 2, 4 should be about here. And so the graph we're talking about is this piece, and it's oriented in this direction. And so the first thing I'd like to get is a parameterization of this curve. This is not a parameterization, even though it is a mathematical geometric description. I want it to be the range of a function. So this curve needs to be a range of a function, and t will have restrictions. Anybody want to do this for me? What is a parameterization of this curve as a function of t? Robert, you want to do this one?
I don't know.
Okay, so that's a fine answer.
I have a question.
Yeah.
So is negative, I don't know, maybe this is just too early in the morning. Is negative 1, is -1, 2 on the graph?
No, I think I've got the graph wrong. I think it's 2x squared. This is number 12 from the book.
Okay.
So this is 2, 8 then. I sort of remembered, but I recorded the function wrong. Yeah, these points need to be on this graph in order to make sense. So I think this is it now. Parameterization, help me out here.
You could do e2t squared when t is between -1 and 2.
Yeah, this is the graph parameterization. This is the one I asked you on the last exam for the top of that region. This is the same problem 1 dimension lower. That was in 3 space, this is in 2 space. So that's the parameterization. And another thing I'd like to compute, because I ask you not only along the curve, as is described in the book, but I ask you across the curve. So you're going to need this vector field as well. This is a different vector field than this, but in the way I introduced this, we'll use this vector field to compute the across. And that would be y squared minus x squared. So if this one is PQ, this one is Q minus P. And now with this information, you're set up to work this problem. And this problem, the way I assigned it, has 2 parts. You want along. You want to integrate the force along the curve, alpha, or C. And the second one is across. And these are different. Integrating force along a curve is going to give you the work done by this force. Maybe it's the wind along C. So how much work is done by the wind? That will be this integral. How much work is the wind doing crossing C? That would be this. So these are 2 very different things you're finding. How much work is the wind doing blowing across the curve? How much work is it doing blowing along the curve? So they both have different answers. This one is the integral of f dot the tangent along C. And this was the integral of f dot. The dot is there because this is a vector field. You want the component in the tangent direction. Here you want the component in the normal direction. So these are the two answers. And from the theory, the second one is equal to the integral along C of f perp, an associated but not equal vector field dot t. So if you integrate f perp along t, it gives you the work done by the force field across force field F across T. So both of these we will find using the same type of formula, integrating in the tangential direction, but we'll be integrating a different vector field. But let's do these one at a time. So let's do along first. So to do this, as an initial check, is F conservative? That's the question. And mathematically, this says, is F a derivative of somebody? Is there an antiderivative for this guy? And we're just going to have to check. Sometimes there is, sometimes there isn't. And the way to check to see if it's a derivative, so I like these derivative pictures vertically. So I'm asking, if you start with x squared, y squared, is there somebody here that when you take the derivative, you get this? And there's a nice little test. You check the mixed partials. If this was a derivative, then the mixed partials are going to be equal. And by mixed, I mean, if you take the derivative of this potential capital F with respect to x, you should get this. And then the mixed partial would be taking the derivative of this with respect to y. Here you get 0. And this would have been the partial with respect to y of f. So if it is a derivative, then the partial of this guy with respect to x would be the same as this. And the derivative of y squared with respect to x is 0. These are equal, so you're good to go. This is, the answer is yes, it is conservative. And this yes tells you how to do the problem. We're going to have to find this capital F and then plug in the endpoints. So this will be F of 28 minus F of minus 1, 2. And that's the answer. All we have to do is find this antiderivative. We good with this? Any questions about this? Okay, so let's see if we can find this antiderivative here. So using the same idea, if this is a derivative, and now we kind of know it is, then you get the antiderivative by integrating, but there is an x and a y here. This should be the derivative with respect to x. So this part should be the derivative with respect to x. So if I just integrate this part, x cubed over 3 plus a constant, and since we're treating y as a constant in this process, any antiderivative of this guy has to look like this. And then doing the same thing for y, the antiderivative has to contain a y cubed over 3 term. And then maybe another constant, but any antiderivative is going to work for this process. And then checking, this one is an antiderivative. The derivative of this function with respect to x is x squared. Derivative with respect to y is y squared. So there is the antiderivative we'll use. We okay with this process? This can be a little more complicated than I just did, but this one is easy. And they all work kind of the same. And you can check. So f of x and y is x cubed over 3 plus y cubed over 3. And so the answer for us is 2 cubed over 3 plus 8 cubed over 3 minus 1 cubed over 3 plus 2 cubed over 3. So that's the answer. Just have to work out the number. And so this number will be in work units, whatever you're using. But this gives the work done along C by the wind. If it's negative, then you're fighting upstream. If it's positive, it's blowing you along. Any questions about this one? Alyssa, are we good with this? And Ben? Ben, what do you think? Are you doing your Greek homework, Ben? Oh, okay. Are we good?
Yep.
All right, let's try it. Let's try the next one, across C. These work this exact same way, but for a different vector field. So we want the integral of f dot n. This is the idea of what we're doing. This is the across part. But what we're going to do is we're going to integrate f perp dot t, because this is the way to do it. And this puts us right back into our last procedure. So the first thing we're going to look at is f perp of x and y. And we already computed this, y squared minus x squared. And we're going to see, is this conservative? One of the reasons I'm doing this is it was a misconception in the first class that if f is conservative, this guy is conservative. And it doesn't work like that. These are different. So doing this check, we check the derivative of this with respect to y. These would be the mixed second derivatives, the mixed partials for the second derivative, if this was conservative. Here we get the derivative with respect to y is 2y, and the derivative with respect to x is minus 2x. These are not equal. And by equal, I mean equal as equations, not just solve an equation or something. These are equal if x is 0 and y is 0, but other than that, these are just not equal. So these are not equal as equations, so this is not conservative. That means there's no antiderivative.
Wait, why wouldn't they be conservative?
If it was conservative, is this Asa?
Yeah.
Yeah, if it was conservative, that would mean this f exists. So then this would be the first partial of f with respect to x. This would be the first partial of f with respect to y. If we took the derivative again,
then the mixed partials would have to be the same, right?
then the mixed partials would have to be the same. So if we took...
But they are, aren't they?
No, they weren't. One was 2y and one was 2x.
But
minus 2x.
Oh, yes.
Those are different formulas.
Yeah, you take the first one with respect to y, no matter...
Exactly, yeah.
Because it had a y in it, then...
You don't get to choose
something
your
else with a
variable.
y in it.
They come. Are we good, Asa?
Yes, yeah.
Actually, what you just said is a very common mistake on exams. Usually, it's not a good idea to talk about mistakes because people remember it, and then on an exam, they think, oh yeah, I remember something about that. Maybe I should do this. But that is a very common mistake on exams, to use the variable that's there rather than the one that you need to use. So are we good though with this? All right. So this is not conservative, no way. So that means you have to go to the alternate, which is the basics, parameterize C. This is always your fallback position. Parameterize C. And fortunately, we already did it. And so that's what we're going to do. So this integral now is the integral of f perp of alpha of t. This is f perp on the graph dot alpha prime of t dt. So what changes here is only this function, f perp. Everything else is the same. You're still doing alpha of t. You're still doing along that curve. So we're going to compute this. We already computed f perp. And now I'm going to plug in alpha of t. Oh, by the way, this is from -1 to 2. And now we're going to plug in alpha of t. Alpha of t is an ordered pair. It is t squared. So the x value is t, and the y value is 2t squared. And that came from this parameterization. And now we're going to plug this into f perp. What are we going to get? Well, you start with the y value squared. So that would be 4t to the 4th. And then then a comma, then minus the x value squared dot. Now you can't integrate just this. This is an ordered pair. We don't integrate ordered pairs. But this takes the dot product with alpha prime. So we've got to compute alpha prime of t, 1, 4t. Here we go. So this sets it up. And now it's basically P and C from here. You have to take this dot product, anti-differentiate, sub in the endpoints, -1 to 2, 4t to the 4th, minus 4t cubed, dt. I'm going to erase the beginning and work up here. But again, this is continuing to be across. Anti-differentiate 4/5 t to the 5th. Mathematical will do this for you. Minus t to the 4th. Between -1 and 2. 4/5 times 2 to the 5th minus 2 to the 4th minus 4/5 times minus 1 to the 5th minus minus 1 to the 4th. That's the answer. This is not the same as the other one. They are different. They're measuring different things. So, and in this problem, you can see how any vector field is integrated along a curve. If it's conservative, you don't have to deal with the parameterization. You just find the antiderivative, sub in the endpoints, you're done. If it's not conservative, then you've got to parameterize the curve and do this process here. Questions about this?